Welcome to my R workshop. I've been running workshops like this off and on for many years now, and some resources related to this version and past versions should be available on my website, which you can access at saraemilyburke.com/stats. Some quick background. I've been using R for statistical analysis and data processing for more than a decade, which means that I have a lot of experience doing certain kinds of things. But there's still a lot about R that I don't know about, and that's because it's highly modular. People write packages to do specialized things, and that's part of what makes R so powerful and also part of what makes it so important to get many different people's perspectives when learning about R as a tool. So don't take mine as the final word. There are whole worlds within R that I haven't touched. And it's okay if you feel that there are whole worlds within R that you haven't touched, because that feeling is normal and accurate, even for very experienced R users. I like to start these workshops assuming nothing about your prior experience with R, but how quickly I go through the various parts depends on what the audience tells me about their experiences with statistical software generally, computer programming, etc. The recording you're watching is from the spring 2020 version of the workshop, with an audience composed mostly of Syracuse University graduate students. We did the first 2 sessions in person and the next 6 online due to the COVID-19 pandemic. I re-recorded the first 2 sessions without the audience using the same online tool I used for the synchronous sessions because it turned out that I liked the recording quality better this way. In the live in-person first session, most participants told me that they knew very little about R to begin with, although 2 were already quite familiar with it. Some had never used R before at all. Everyone had previous experience with some kind of statistical software, though. In most cases, that software was SPSS. I did the workshop using the default R GUI, graphical user interface, or GUI, is a visual system for giving instructions to the computer for some kind of software application. R comes with a default GUI, and that's what I'm going to be using for this workshop and what you're going to see in the video in a moment. It seems like most people use RStudio as their primary R GUI, and it has certain advantages and certain disadvantages. Download links for R and RStudio are available in the PDF summarizing this workshop that is on my website. In order to be able to walk through specific examples of code and output in R, I'm going to be sharing my screen, and I'm using this tool. So at various points throughout the workshop, you might see this infinite tunnel of web browsers. That's because I'm on my way to showing you the R software itself. You can't see my mouse the way that I'm recording the screen, so I will use selecting text in either the console or the script file that I'm working with in order to call your attention to particular things that I'm talking about at any given moment. If my text selection is slightly imprecise, please forgive me. What you're looking at right now is the GUI that comes with the default R installation. This part is the console, the most important part of any R GUI. That is where you give the computer instructions. Next to the console, on the right side of the screen, I have open a text file containing the code that I'm going to run in this session. For now, you don't need to pay much attention to that file because I'm only using it to run code at the console, and I will explain each line of code step by step by looking at the console and thinking of what it's doing in terms of instructions that I've given to the computer and responses to those instructions from the computer. That is input and output. At the console, in general, you tell the computer what to do, and then you see what it does. If you want to do something that I haven't covered in this workshop, you're welcome to reach out to me via email. But also you can try searching the internet using a search engine such as Google for help with your task. There is a lot of helpful information about how to use R on the internet, and many active communities of R users generating new questions and new answers all the time. Among the resources available is my own website, where there's a summary of the introductory portion of this workshop, links to these videos, etc. The URL is saraemilyburke.com, and the Statistics tab has a variety of stats resources. So if I visit saraemilyburke.com and then click on the Statistics tab, you'll see some of those resources. R is a programming language, so in my opinion, it makes sense to start out with the basics of programming rather than with statistical applications. But I promise we'll get to some statistics soon. The point is to show you that you are in control of what R is doing every step of the way. As you build the intuition that R is listening to your directions, it will help you understand what is happening as you process and analyze your own data, even when things go wrong. When something does go wrong, you can start to think of the situation more productively as you gave instructions that you didn't intend to give, rather than it didn't work. The basic intro to programming in R may not be the most fun or exciting part of this workshop, but in my opinion, it's necessary. I think of it like learning how the steering wheel and pedals work in your car before you move on to mapping out where you're actually going to drive. In contrast to many other common programming languages that you may have seen before, like C or Python, R is specifically designed for statistics and set up in a way that makes common data analysis tasks convenient, which is why we will soon be talking about those sorts of tasks. When you start R, you're going to see something like this at the console. That's just boilerplate information about the current R installation. Mine is a bit out of date. The console functions like a command line interface. So if you try typing in a command like 3 plus 3, then you'll see the result, which is 6. The input that I gave R, the 3 plus 3, is in this version of the GUI printed in red next to this greater than sign indicating a prompt to supply a command, and the output is this number 6. To tell R to assign a value to a variable, you will type the variable name followed by an equals sign. So for example, this line of code, which I'm just going to run from the syntax file now, but you'll see it at the console, x equals 3 sets the value of the variable x to 3. X can be any arbitrary name. That is something that I made up. I chose to use the letter X. The instruction I said here, that instruction that I gave to R here was to remember the value 3 with the label X. And if then I execute the command just X, then that's like asking R, what is the value of X? And R tells me that the value is 3. I can also do things like x plus 1, and R will return the value 4, or x times 2, and R will return the value 6. I can change the value that I've assigned to x by assigning it a new value using the assignment operator again. The single equals sign here is functioning as the assignment operator because it's part of the instruction telling R what information to store using the variable label x. So if I now execute the command x equals 4, and then execute the command x, R will tell me 4, because that's the new value stored in x. The assignment operator takes the value on the right and gives it the name on the left, never the other way around. So if I attempt to execute this line of code, 3 equals x, it should result in an error message. The reason that this results in an error message is because I cannot assign a new value to the label 3. 3 is special. It represents the quantity 3 for R no matter what. I can't change what that means. But I can change what the label x means because that is a valid arbitrary variable name. To reinforce that directional feature of the assignment operator, you can also write the assignment operator with a 2-character symbol, the less than sign and the hyphen, forming an arrow like this. So if I run this line of code, x less than hyphen and then 5, where the less than and the hyphen there's no space in between them, then it's like x arrow 5, and it's telling R to remember the value 5 with the label x, just like the single equals sign did a second ago. So now x contains the value 5 instead of 4 or 3 like it previously did. You can use any string of letters as a variable name. For example, I can assign turtles the value 2 plus 7 plus 13, and now that variable exists where it didn't before, turtles, and it contains the value 22. It's also therefore acceptable to do arithmetic on the right-hand side of the assignment operation. So that's how a lot of the things that we do in R are going to take place. They're going to involve carrying out some kind of computations and assigning the result some label that we'll refer to later. Note that names in R are case sensitive, so capital T turtles is different from lowercase t turtles. And if I tried to ask R what capital T turtles is, it would tell me error, object turtles not found. This can be helpful because you want to make sure that you're not assigning some variable name that already exists with some other purpose. So by testing out capital T turtles, I can see that it doesn't exist yet, and I could use it for some other purpose. But I wouldn't recommend having two variables that have the same name except for capitalization, not because it messes up the computer in any way, but because it's typically confusing for humans if you do it that way. Basic arithmetic works more or less like you would expect in R. So if I run this line of code, the value of x will be 9 because R carried out first 2 times 7 for 14, added 4 to it for 18, and then divided it by the quantity 1 plus 1, which is 2. 18 divided by 2 is 9. So the order of operations is sensible, and parentheses work like you would expect from algebra. I can also use the caret symbol to represent exponentation. So x minus 3 squared, or 3 caret 2, is 0 because x is still 9, so subtracting 9 from it would result in 0. Although most of the logic of algebra works well here, don't make the mistake of assuming that you can leave out the multiplication sign like you can in many algebraic situations where you're writing things out by hand. If I write 3x, it's going to give me an error message because I haven't, R does not interpret numbers that are immediately adjacent to letters as being multiplication. If I did 3 times x, that would give me 27. That's a good thing because I should be allowed to have a variable called x3, for example, and not think of that as x multiplied by 3. That variable does not currently exist, which is why I get that error object x3 not found message. If you don't finish a line of code, the console will prompt you for the rest of it with a plus sign. Many programs that are written in R feature lines of code that actually take up more than one line in the text file, and this can be quite handy. So if I type x/ at the console and then enter, there's a little plus sign waiting for me to finish the line of code. So 2 and then enter again results in 4.5 because 9 divided by 2 is 4.5, and x still contains the value 9. We haven't changed it since we set it to 9 right here. The reason that R knew that I wasn't done with this line of code yet is because x/ is not a complete line of code. If what you type is a complete valid line of code, then R will just execute it. But if what you have typed is an unfinished line of code, like could be a valid line of code if there was more to it, then R will wait for you to finish the valid line of code before attempting to execute it. And the slash symbol represents division, so R is waiting for the denominator of that division. Sometimes you'll hear R users have conversations about which assignment operator is better. That is the single equal sign or the less than hyphen arrow assignment operator. They're both valid though. There are some cases where one makes more sense than another, but in the vast majority of real-world applications of the assignment operator, they can be used interchangeably, and it's okay to have a personal preference. I am going to use the single equal sign most of the time in the code examples that I share with you.